Okay, so far you have done one problem of practice on your own, and now we're going on to, there's two more in this you try section. The next one is number 9, and it reads, the monthly rent for an office of size 800 square feet is $975. An office of 1,100 square feet rents for $1,125. If X represents the size of the office and Y represents the cost, the first thing we want to do is, or the goal of this problem is to write the equation of the linear model that represents the situation. Each time we are given a problem and we want to write an equation, or if we want to find the slope, what we need to do is decide what type of situation is this. Am I given 2 data points, or am I given an initial value and a slope? So as I read through the problem, I do start to notice that I have a set of data, a set of points that go, or a set of information that goes together. I see that I have 800 square feet that pairs with $975. And then looking further into the problem, I see I have 1,100 square feet that pairs with $1,125. So I have these 2 pairs of information, which means I have a problem where I'm given 2 data points. And so when I have a problem where I'm given 2 data points, I want to write out those points so I can find the information I need, in this case, the equation. So that's what you're going to do to start this. I'll go ahead and kind of set you up, and then you can work through and finish this problem. I do want to give you a little hint that in this situation for your linear model, it will be okay to give your values as decimals. We have large values, and it ends up working out where you're going to need decimals for this problem. Okay, I'm going to go ahead and give you another hint on number 10 before I let you go to start working on these 2 problems. So number 10 reads, in Arlington Heights today at 11 a.m. the temperature was 41 degrees Fahrenheit and is falling at a rate of 3 degrees per hour. Again, our goal is to write the equation in line, so as I look at this problem, I'm deciding, is it a situation where I'm given 2 data points, or am I given the slope and a starting value? So as I look at this, I do see a data pair. I see that I have 8 a.m. paired with 41 degrees. As I continue on, do I have a second pair, or am I given something about the slope? As I continue on, I read it's falling at a rate of 3 degrees Fahrenheit per hour. Oh, there's that word, that per. That per is a key word that we want to keep an eye out for in these situations. That per tells me I have a rate of change, or a slope that's given. So this problem is a situation where we're given the slope and a starting value. Okay, as always, finding that slope is the first thing we need to do to write our line, write our equation for our line, and then you need to go ahead and use the starting value to help you write that equation. Now I do want to make one change here. We've done a lot of problems that already ask us to do questions like this, so I want to actually give us a little more practice on the other type of question. So I want you to change that statement to say, when will the temperature be 32 degrees? Okay. So we're going to answer that question instead. Okay, pay attention to the fact that we're talking about a time, so try and actually give this as a time as opposed to a number of hours. Okay, please pause the video now. Take this time to work on problem number 9 and 10. So again, press pause on your video and start working on number 9 and 10. Okay, hopefully at this time you've completed number 9 and 10. Here are the solutions for you to check your answers. Now, not that the work is not here, so you should have a lot more work than what's here. But you can check to see that you have the correct data points. If you don't have that correct, fix that right now and then go back and try and redo this equation. If those are correct, then obviously check your equation, make sure that's good. If you gave your slope as a decimal, that would be perfectly acceptable. And then here's our solution for part B. And then checking number 10. Okay, number 10 is not going to have a whole lot of work. When you're given slope and the starting value, you can go ahead and write your equation in y equals mx plus b form right away. B being your starting value and your slope being your m. And then you do have some work to do to solve to find part B for that problem where you're determining what time. you do get an x value that should be 3. And so if you have an x value of 3, then you need to identify that that's 3 hours since 8 a.m. And since 8 a.m., 3 hours later would be 11 a.m. Okay? All right, if those are good, then you're going to continue on with us right now. If those didn't go well, then you're going to pause this video right now and raise your hand so that Mr. Meyer, myself, or RA can help you work through these problems today. So please take this time to get your questions answered if those did not go well. If they did go well, then we're going to continue on to the extension. All right, our extension is talking more about our concept of rate of change. It's getting us into slope. We're looking at real-world scenarios. We're looking at situations that are modeled for us. So in our extension, we're looking at data. And the question we're going to be asking ourselves is does the data show, and these are our 3 options, a positive correlation, a negative correlation, or pretty much no correlation? Okay, if you don't work the word relatively, that's fine. You can just write no correlation. So we're looking for positive correlation, negative correlation, and relatively no correlation. Correlation is explaining whether the points have a pattern. Do they have some sort of pattern that goes with them to help us be able to make predictions for future values or figure out earlier values or even values in the middle? So part A gives us a table of temperatures versus costs. Not exactly entirely sure what this represents, as we're not given a title to it, but it's some representation of how a temperature determines a cost. So as I look at this data, the question I need to ask myself is it relatively forming a line? Okay, and as I look at this data and kind of think about maybe more of a broad line, I do see that if I even put my pen over it, that line with my pen can cover all of the data. This data does follow a linear pattern. It's not perfectly in the form of a line. I can't draw a line that goes through every single one of those data points, but it is in a general linear pattern. And what I notice about that linear pattern is that it is a line with positive slope. It's a line that from the left to the right is going upwards. If that's the case, then we say, because this data is roughly in the form of a line with a positive slope, we say that the data has positive correlation. Let's look at B. Here we have a graph that shows the car weight versus the miles per gallon. Okay, this is pretty straightforward. We're just testing to see what the general miles per gallon would be compared to the car's weight. And so as we look at this data, it's a little less in the form of a line, but I do still see a pattern. It seems that as the weight gets larger, okay, maybe this is in tons, the miles per gallon begins to decrease. The more the car weighs, this less I get in terms of mileage per gallon for that particular car. So as I look at this, I could kind of draw a line, something along this line, that roughly estimates that data. It's not perfect, but it is somewhere in this frame. Okay, the data is decreasing at about that pattern. And so I see it's a line with negative slope. It is relatively linear in the pattern of that data. So we would say that this data has negative, because the line is going down, so it has negative slope. It has negative correlation. Let's look at one more example to kind of get a better idea of what this correlation idea is. Okay, example C talks about temperature and the residuals from a straight line model. I can't even tell you what that exactly means. But we're looking at a temperature versus some sort of calculation. As I look at this data, it's all over the place. As I move to a lot higher temperature, I cannot tell you with any sort of methodology whether the value would be getting larger or smaller. If I wanted to figure out what would happen at 100 degrees, there's no reason to guess that it would be something larger or smaller. All this data is all over the place. There's no way I could draw a line that roughly estimates this data. Here's a situation where I have relatively no correlation. So what we're looking for in this extension is, one, just to understand the idea of positive and negative correlation, and then how that compares with a situation where there's no correlation. And then we're also going to be looking at making our own scatter plot and then determining that same piece. So number 12 says the table shows the amount of hours of television watched at home during the week versus someone's GPA. We want to draw a scatter plot of hours of television, which is our X, versus the GPA. So typically we do want to label our graph, so we're going to squeeze it in here. We're going to put hours of TV here along the x-axis. Oops, sorry about that. There you go. And then we're going to put GPA along the y-axis so that we have a graph that's labeled. Now we're going to plot these points. It says for 5 hours of TV, we have someone with a GPA of 5. With 9 hours of TV, we have someone with a GPA of 4.3. And then here we have someone who watches 20 hours of TV in a week, and their GPA is down at 1.2, so here's 20. We're going to plot 1.2. Then we have someone who watches an average of 12 hours of TV each week, and their GPA is up at 2.5. We have our next person who watches only 4 hours of television, and their GPA is up at 4.9. Okay, we have someone who watches an average of 15 hours of television with a GPA of 2. Someone who watches 6 hours of television with a GPA of 4.7. Okay, as I'm plotting that, it's a little bit above half. That's really what I'm thinking. Is it greater than half? Or is it closer to the half or closer to the 5? You know, trying to estimate those points well. And then finally, 7 hours of television and 3.6 is their GPA. So we've plotted all of our data. Now we need to look at this data. The question's asking us, is this a positive correlation, negative correlation, or no correlation? And then why? So as I look at this data, I see a pattern. I see that the data is, 1, going down. If I were to make a prediction for someone who watches 25 hours of television, I would say it's something less than 1. Okay. This data does follow a linear pattern. It's, again, not going to plot to be a perfect line, but I can draw a line. Okay. It's kind of nice that Stephen put my pencil down because it's a little wider and I can see that I cover up a lot of those points. I show that general pattern, but we'll go ahead and draw a rough estimate of a line through here. Okay. It's not perfect, but I see that pattern of decreasing. And I see that this is giving me a way to make future predictions, or predictions in the middle, or predictions prior to the data that I have. Okay, I see that as the number of hours of television increase for the week, on an average week, the GPA in general goes down. Okay? So looking at this situation, I would say that this has negative correlation. And how we can, explain that might simply be the statement saying the y values decrease as the x values increase. Okay. That's what our idea of negative slope is. And in this case, when we're looking at data, it's the idea of looking to see that there's a general pattern that follows that idea of negative slope. The y values decrease as the x values increase. Okay? All right, and that is what our extension covers, the idea of positive correlation, negative correlation, or no correlation. At this point, I want you to go ahead and take your practice 2 packet out and complete working on the rest of those practice problems that are in that packet. Thank you.